If we want to multiply rational expressions, we do it just the same way that we multiply fractions. That is, we multiply the numerators, multiply the denominators. Notice when we do this, we need to write our numerators and denominators in parentheses, since the fraction bar acts as a grouping symbol. So technically speaking, I've just done the multiply step. I've just multiplied these two rational expressions together. But I bet I can simplify. If it didn't say simplify, I would be done right now. But in this case, I do want to simplify. So I'm going to go through each one of these factors, and I'm going to factor that. We have the 5x squared minus 25x, the x cubed minus 8, the x squared minus 3x plus 2, and finally, the x squared minus 25. I want to factor each one of those. So I'm going to just kind of do this off to the side. 5x squared minus 25x. Those have a common factor of 5x. And we'll be left with x minus 5. The remaining polynomial factor is linear, so that's as factored as it gets. X cubed minus 8, that's x cubed minus 2 cubed, a difference of cubes. So that factors. First factor is x minus 2. And then the second factor is every possible combination of two of those. So we'll have 2 copies of x, that's x squared. We have an x times a 2, that's 2x. And then we have 2 copies of 2, that's 2 times 2 is 4. This first factor is linear, and the quadratic factor we get out of difference of cubes is basically always prime. Next, we have an x squared minus 3x plus 2. So that's 3 terms. We're going to use the AC method. We have a leading coefficient of 1, so we can use the shortcut. We need 2 numbers that multiply to positive 2, add up to negative 3. Well, we'll want negative numbers. The only numbers that multiply to 2 are 2 and 1. And yeah, negative 2 plus negative 1 does add up to negative 3. Finally, our x squared minus 25, that's a difference of squares. It'll factor as x minus 5 times x plus 5. We have now fully factored our numerator and denominator. And I'm going to give myself a nice long fraction bar so I can fill everything in. In my numerator, I had 5x squared minus 25x, which I now know factors as 5x times x minus 5. I also had x cubed minus 8, which I now know factors as x minus 2 times x squared plus 2x plus 4. In my denominator, I had x squared minus 3x plus 2, which I now know factors as x minus 2, x minus 1. And then I have this x squared minus 25, which I now know factors as x minus 5 times x plus 5. So what can we cancel out? 5x does not appear in the denominator. We'll leave that. X minus 5 appears in the denominator. X minus 2 appears in the denominator. And that's it. We'll have 5x times x squared plus 2x plus 4 all over x minus 1 times x plus 5. And then we can leave it like that, or we can multiply it out. We'll get 5x to the third plus 10x squared plus 20x, distributing in the numerator. In the denominator, x times x is x squared. We've got x times 5 minus 1 times x, so plus 4x. And then we've got negative 1 times 5 minus 5. Our product of two rational expressions then is 5x to the third plus 10x squared plus 20x all over x squared plus 4x minus 5. Just like with numbers, instead of multiplying two obvious rational expressions, we can multiply a rational expression by a polynomial. In this example, we have 3x plus 5 over x cubed plus 27 multiplied by the polynomial 3x to the third minus 9x squared plus 27x. In order to be able to do this arithmetic, we're going to understand this polynomial as a rational expression with denominator 1. And therefore, if we multiply the denominators, we'll have 3x plus 5 times 3x cubed minus 9x squared plus 27x. That's our numerator. Our denominator is x cubed plus 27 times 1. I'm going to write that times 1 in there so that I know I haven't forgotten it, but I know that multiplying by 1 doesn't do anything, so I can just ignore that times 1 in the coming steps. Nothing here looks too difficult to factor, so I'm just going to kind of factor as I go. First I have this 3x plus 5. That's linear, so it's prime. I'll just copy that. 3x plus 5. Then I have this 3x cubed minus 9x plus 27. I recognize those have a common factor of 3x. And then the remaining polynomial is going to be x squared minus 3x plus 9. Now, I kind of recognize that as that polynomial I get from a sum or difference of squares, so I suspect that's not going to factor. Our AC is 9, our B is negative 3. So we're looking for a pair of negative numbers that multiply to give us 9. Negative 1 times negative 9 is 9, but negative 1 plus negative 9 is negative 10, not negative 3. Negative 3 times negative 3 is 9, but negative 3 plus negative 3 is negative 6, and that kind of exhausts my options for factors of 9. this trinomial here is prime. We had to check. We kind of suspected it was going to be prime. It turned out it was. So that's my numerator fully factored. In my denominator, I have that x cubed plus 27, which is equal to x cubed plus 3 cubed. So that'll factor as an x plus 3 times every possible combination of two of these, right? We have an x squared. The second term is negative for the sum of cubes. So minus 3x. And then the last term is 3 times 3 is 9. Okay, well, that's lucky. I see that's a common factor that I can cancel out. And so I'll be left with 3x times 3x plus 5 in my numerator, and just x plus 3 in my denominator. You might be thinking, hey, can I cancel these 3's? And the answer is no, you cannot cancel those 3's because the one in the denominator isn't a factor, right? We're not multiplying by 3, we're adding 3. Now we could leave this in this form, or we could distribute in the numerator to get 9x squared plus 15x all over x plus 3, which is our final product. 9x squared plus 15x over x plus 3.